Okay, so what we are doing is going to start chapter 8. And chapter 8, you have to be able to simplify radicals. And some teachers in algebra covered this to greater extent than others. Okay, so we're kind of going to spend the next 2 days just going over what I think you need to know to be able to do this chapter. No calculators, so put those away. Okay, you cannot use a calculator on this. Like I said, we're going to spend 2 days, and then probably next Thursday, I'm going to give you a quiz, and you will not be allowed to use your calculator. Okay, so don't enable yourself by relying on the calculator because you got to be able to do it without it. Okay. All right. And for those people that are absent today, I know I'm not talking to them, but I'm just saying this for my recording. We are actually doing a different worksheet. I have uploaded it, but they will be okay because I will just write what I assigned them. So it doesn't really matter. I just changed my mind on which worksheet that I wanted to do. All right, and so today, like I said, we're talking about radicals. This little symbol here is your radical sign, okay? And the number underneath it is called the radicand. Now, when you take this, you also say take the square root of something. When you take the square root of something, you're looking for what number multiplied by itself will give you that radicand, okay? And I cannot think of a number multiplied by itself that's going to give me 18, right? If I plug it into the calculator, it's going to give me this big long decimal because this is an irrational number, okay? There's not an exact number that can be multiplied by itself to give you 18. But what we can do is simplify radicals like this, okay? Now, the square root of 25, or radical 25, there is a number multiplied by itself that gives you 25. What would that be? 5. There's another number, too, because really every number has two roots, a positive root and a negative root, right? We are primarily going to focus on the principal square root, which is the positive square root, okay? That's really all we're going to be working with. Now, I've listed several of the perfect squares, okay? And you need to know this, okay? You need to be able to recognize that 4 is a perfect square because the square root of 4 is what? 2. You get a whole number, okay? What is the square root of 100? 10. How about the square root of 81? 9. How about the square root of 49? 7. Square root of 25. Already talked about that one. 5. Square root of 1. Square root of 16. What about the square root of 400?
20.
Think about it.
20.
20. I skipped some right there. What's the square root of 225? 15. I skipped some in between there. How about 144? 12. 196. 14. 169. 121. 11. 9. And 36. And 64 is 8. Now, you don't typically get those in order, right? So you really need to be able to recognize that those are perfect squares. Okay? All right, now, 13 and 14, okay? One way that I remember it, 169 is an unlucky streak because there's lots of wrecks, right? And 13 is kind of an unlucky number. And then 14, you just switch the 6 and the 9, okay? That might be a one way that will help you remember it because as the numbers get bigger, it does get a little bit trickier to remember them. Like 225 to 400, I don't know those very well, which I probably should, but I don't. But I definitely know the ones up to 225, and I recognize that the square root of 400 is 20, because 20 times 20 is 400. All right. Now I'm going to talk about the product property of square roots. When you take the square root of a number, okay, you can break that number into two factors. Every number has two factors, right? At least two factors, okay? So I can take the square root of a number and break it into the square root of A times the square root of B, okay? When you break it up, however, you want one of those factors to be a perfect square. Now, some teachers teach these little factor trees. I'm not a fan of the factor trees. I'll just be honest with you, I hate them, okay? And there's nothing wrong with them. I just don't like it. I think it's better if you learn how to work through perfect squares, okay? Occasionally, I'll do the division ladder, and some teachers teach that with a lot of success, and that's good. But like I said, sometimes I use it if the number's really big. But But these simple ones, you really, really, really need to be able to recognize perfect squares that divide into those numbers. Because like I take 18 and I want to break it up into two factors, one of which needs to be a perfect square. So what would you break 18 into? 2 and 9, right? Okay, because you want two factors, not 2 is a factor, but you want the factor pairs, okay? And you want one of the factor pairs to be a perfect square. Now I always put the perfect square first, okay? Because you're going to take the square root of that. What's the square root of 9? 3, and it is going to go in front of the one that you can't take the square root of, okay? And that's your final answer. How can I break 24 down? Okay, but 8 or 3 are either one of those perfect squares. Okay, I would probably use 6 and 4, okay? So I'm going to break this into the square root of 4 times the square root of 6, and what's the square root of 4? 2 times the square root of 6. Did you have a question?
What I was like, if the square root of 7 was like, that was
It is, because the square root of 4 is 2 times 2, right? I'm really shortening my work by not doing it the other way, right? Because I'm recognizing that 4 is 2 times 2, and that's why it's a perfect square. So it is the square root of 4, which is 2. If I had done the factor tree version, you know, I would have done 4 and 6, 2 and 2, and 2 and 3, right? And here's a pair, so that's where I get the 2 from, and then the 2 times 3, which is 6, okay? But in my experience, I get lost when you break these branches in a tree, okay? Some teachers do upside down division, like a division ladder, and so they divide by 2, which is 12, they divide by 2, which is 6, they divide by 2, which is 3, and they divide by 3, which is 1. 1. Okay, so again, they get 2 times 6. Okay? I don't care if you do it that way. That's fine. However, for these little numbers, I think it would... These is really good for big numbers, okay? But for the little ones, it's really good to where you recognize those factor pairs, one of which is a perfect square, okay? And it's going to help you, I think, later on in your math, okay? And I tell you this because, for example, my son, I was helping him the other night, and he had a problem in which ended up being he had to multiply 2/3 times 1/2, okay? And he's a good math student. He's not great at fractions, okay? And so and it was more than just this. It was like taking 2 to the 2/3 power and then taking that to the 1/2 power. But ultimately, you had to multiply 2/3 times 1/2. Well, I was able to look at that and just say, okay, well that's 1/3 because the 2's cancel, right? Okay. But he proceeded to get out his calculator and he was going to plug all his fraction stuff in there, which some of you have been guilty of, yes? Yes? Okay. Because you don't want to do it in your head, or you're not you're not confident in yourself for whatever reason. But if you look at the big picture, when you go to take the ACT, you only have so much time. You're doing like a problem every 30 seconds. And if it's taking you a whole minute to plug 1/2 times 2/3 into your calculator, that is precious time that you need to be able to solve other problems. And so if you can do those kinds of things in your head and do things more quickly, that's going to definitely be to your benefit, okay? So, they've been trying to teach you guys fractions forever, and some of you just dug your heels in and say, I'm not going to learn it because I can use my calculator. Okay, but you're going to waste a lot of time when you go to take a big important test that's going to help you to get into college. Do you see what I'm saying? So, there's certain things that you really need to get good at. This being one of them. And this, this is going to save you some time as well. Okay. All right, how about 32? Okay, somebody said 16 and 2. Good. The square root of 16 times the square root of 2, which is going to be 4 radical 2. Now, how many of you thought 4 and 8? Okay. So, this is great if you can see 16 and 2. Okay, that's awesome. But sometimes we don't see the biggest perfect square. And so, let's say we did the square root of 4 times the square root of 8. We can still get there. It just takes us 2 steps, or 3 steps, however many steps. Okay? Square root of 4 is 2, and we have the square root of 8. But 8 has some perfect square factors in it, so it's truly not totally simplified yet, okay? Because what can 8 be broken into? 4 and 2. So that's what you would do, okay? And the square root of 4 is what? 2 times the 2 that's already in front of it. Because you have to take that square root, 2, and multiply that by that 2 that's in front of it. So we end up with 4 radical 2. What about 48? But 6 and 8, neither one of those are perfect squares. Okay, 16 and 3 is your biggest, right? Which would be 4 radical 3. What did you say? Okay, and 4 and 12 would work. Again, it might take you a few steps. If I did 4 and 12, it's just like this one I did over here. I would have got 2 radical 12, but then I would have had to have broken 12 up into 4 times 3, which is 2 times the 2 that's already in front. So, that's going to give me 4 radical 3 as well. Okay? So if you don't think of the biggest one right off the bat, that's okay. Now let me tell you just a couple of tricks. Okay? You want to try to use the biggest perfect square possible. And the biggest perfect square possible is always going to be half or smaller. It's never going to be bigger than half. Alright? So if it's a kind of a big number, you might try some of your perfect squares. There's some rules that you might want to follow back from 6th grade, maybe even 5th grade, your divisibility rules. And one of them would be like if I had 124. Okay? 4 is a perfect square. Do you remember the divisibility rule for 4? Anybody remember the divisibility rule for 4? You look at the last 2 numbers, and if 4 will divide into the last 2 numbers, then it'll divide into the whole number. Okay? Even if it happens to be like 200, 00, 4 divides into that. Okay? So 4 would divide into both of those. Okay? The divisibility rule for 9. 9 is a perfect square. Okay? So if I had 225. No. 234. Okay, 234. Okay, you remember the divisibility rule for 9, Harley? Now, if you add up all these digits, 2 plus 3 plus 4, and that ends up being a number that 9 divides into evenly, then 9 will divide into that whole number. Okay? And 9 is a perfect square. Alright? So don't forget about some of those rules that are out there for you. Okay? Alright. Now we're going to get down here, and there's like 4 problems that I have typed up here but are not on your notes. So when it gets down to the fractions, okay, I'm going to add 3, and we'll cover those other ones on Monday. Okay? Alright. Now, we're going to work backwards. And when we work backwards, what we do is we have 2 factors, and we multiply them together and get a number under the radicand, and then see if we can simplify that number under the radical and see if we can simplify it. So if I take radical 5 times radical 5, okay, that would be, you would multiply 5 times 5, and then it goes under the radical. But what is the square root of 25? 5. Anytime you multiply a radical by itself, it's that number without the radical. So radical 7 times radical 7 would be what? 7. Radical 2 times radical 2 would be what? Okay, so anytime you multiply a radical by itself, it's that number without the radical. Alright, now, these numbers are different, okay? So if I took radical 8 times radical 5, what would that be? That would be radical 40. But then I have to look to see if this radicand has any perfect square factors. Does it have any perfect square factors? 4, okay? So this can be broken into the square root of 4 times the square root of 10. And what's the square root of 4 times the square root of 10? 2 radical 10. Okay, because the square root of 4 is 2, and then radical 10, doesn't have any perfect square factors, so it doesn't. Alright, radical 2 times radical 6, what's that? Radical 12, and what can I do with radical 12? Okay, so I take the square root of 4 times the square root of 3, the square root of 4 is 2, and can't do anything with the square root of 3. Okay, here's another one. Now, on this one, these have coefficients in front of the radical, okay? So when you have coefficients in front of the radical, you multiply what's outside of the radical together, and it stays on the outside. You multiply what's inside the radical together, and it stays on the inside, okay? So I would take 4 times 2, which is 8, and radical 3 times radical 6, which is radical 18. And then I look to see if that can be simplified. Okay, can we break 18 down? Okay, 9 and 2. So we have 8 times the square root of 9 times the square root of 2. square root of 9 is what? 3 times the 8 that's already there. And so 8 times 3 is 24, and then my radical 2 tags along. Any questions on what I've done so far? Okay, what about 2 radical 5 squared? What does it mean to square something? Multiply it by itself. So we've got 2 radical 5 times 2 radical 5. Okay? So we multiply what's outside together. That's 4, right? And what's radical 5 times radical 5? 5 times the 4 that's already there. So it's going to be 20. Now, really, I could go from here to here, okay? From step 1 to step 3. Because if I square 2, it's what? 4. And if I square radical 5, it's 5. So 4 times 5 is 20. Okay, I'm just kind of breaking it down for you so you can see how I got there. Okay, now I think these next 4 problems are new. So you'll probably just put those over to the side or on that sheet of paper. All right, here I got 7 radical 8 times 2 radical 5. What do I do? Yes. Okay, 7 times 2 is 14, and then radical 8 times radical 5 is radical 40. Can 40 be broken down? Yes, we've already done one like that, haven't we? So we break it into the square root of 4 times the square root of 10. Okay, we take the square root of 4, which is 2, times the 14 that's out front, and so we end up with 28 radical 10. Okay, now we notice that some of our coefficients have negatives in front of it, but does that change the problem? No, we just have to follow our integer rules, okay? So on this one, what are we going to have here? I got negative 24, and then radical 2 times radical 2 is 2, and then negative 24 times 2 would be negative 48. Good. All right, what about this one? Okay, multiply what? 10 times what? 10 times 10. 10 times itself, right? Because you're squaring it, right? I don't know. That's why I asked. I couldn't tell if you said 10 times 10 or 10 times 2. That's why I said 10 times what? Okay, so you square this. So 10 times 10, which is 100, right? And then what do you do with the radical 6? You square it, which means it's 6. And 100 times 6 is 600. All right, last one. What do you think? Okay, what do you get? Positive 27 times radical 20. Okay, am I done? No, because this radical 20 has a perfect square factor, right? Okay, so what does 20 break into? Okay, 4 and 5. Now I heard somebody say 2 and 10, but 2 and 10, neither of those are perfect squares, right? So I probably wouldn't want to use those. I want to use something that's got a perfect square. Okay, so I end up with 27 times 2 times radical 5, which is going to be 54 radical 5. Isn't that fun? I think it's kind of fun. It's quick, right? Okay. Any questions? Make sure that when you're done, that what's underneath the radical doesn't have any perfect squares. Okay? All right? Make sure. That's one thing you got to make sure of. All right. We have our worksheet. We'll finish these notes, plus I'll add a few more like I did today. We'll have another worksheet on Monday. Okay?